Now, the today lecture is about the HR diagram. HR diagram. What is the meaning of HR? That's a very difficult name of the scientist. That's a German scientist, Hertz Bring. There's a Hertz Bring, one name, and the second name is Russell. Russell. That's fine. This
Yes,
is the
sir.
meaning of diagram. And you have seen this question into paper, these words into the paper, okay? And this is the basically this person has worked for the stars can how they work. What is this diagram about? That the stars can be classified. So means different star can be separated by plotting a graph of luminosity. Do you remember luminosity?
Yes, sir.
Okay, that's good. Against temperature, okay? Against temperature. It's fine.
Yes, sir.
Okay, just 1 minute, okay? Okay, have you understand that? This is the basically the purpose of this graph, okay? I will draw the graph later because the graph is little bit tricky. So let me write first, okay? So what they have written the main points. The main point which is written by him is that the surface temperature, the surface temperature of a star floated, sorry, floated against against their power, their total power means luminous relative to the luminous luminosity of our sun. Okay,
Yeah.
it's fine.
Yes,
Yeah.
sir. So on the
It,
x-axis, sorry.
yeah, yeah. Please, please.
So on the x-axis will be surface temperature, or
Exactly.
on the
I think this diagram is made in your book. I think. Can
uh
you see?
oh yes, sir. Yeah.
Okay, it will be difficult for me. Let's see the book here. That is in book 2, I think.
Yeah.
Can you tell me the page number?
Page 184.
184 means so that's good. One. There are a lot of diagrams. Yeah, this is the basically diagram. Let me share the diagram with you. Then we write up again. Okay. Have you noted that what I have written?
Yes, sir.
So now, this is the sun, okay? This is not the LUN, this is the sun. Okay, let me
Mm,
share the diagram with you.
yeah.
Then first we're going to discuss the diagram because this diagram maybe sometimes come into the paper. Okay, let's write from the diagram. This they have written here. This is super joint. Super joint, that's a red joint. That is the super red joint, rent super joint. So what is the difference between red joint and red super joint? This is the medium star, and or you can say average stars. Okay, the low and the medium both is coming, and that is the massive star. It's fine.
Yeah.
Okay, and if you see here, we have the white dot. So when I wrote the life cycle of the stars, you will note that. Okay, what? But I have written there. What do you mean by life doves? Kindly note that the white dove. Do you know dove? What is dove planet?
Yes, sir. Like Pluto.
Exactly, the planet which is approximately equal to the size of our moon, which is not in the categories of the planet. Okay, so so white dwarf have the high surface temperature. By the way, this is not planet. Okay, this is a star. Okay, there's a high temperature and low luminosity. Why it is high temperature and low luminosity?
Um, it doesn't give out much light.
Okay, so we can say we have the equation like that in which the luminosity and the temperature have the relation,
Yeah.
but it
So
is not. It's a Wien-Stefan law, and in Stefan law we have the direct relation.
yeah.
But then why here they have written like that?
Mm, because it's an inverse relationship.
No, they have written that if you remember this equation is L sigma A T4. If you remember, this is the equation I think.
Yeah. Yes, sir.
And but we have another law that lambda maximum is inversely proportional to temperature. So see this law, this explanation with respect to Wien's law. Okay. So
Okay.
because the wavelength of the white light is very less, so that's why its temperature is high. Okay. That's why
Yeah.
its temperature is high. Okay. It's fine. But why its luminosity is low? Because its surface area is um comparable. So that's why it is the basically low luminosity. Like if I want this equation of Boltzmann-Stefan law written for the temperature, so I can write L is equal to sigma A. So it means temperature is inversely proportional to area. So it means if the area is smaller, the temperature will be larger. That's fine. But their relationship, the luminosity become low because that is also directly proportional to the area. Yeah,
Yes, sir.
it's fine. Now,
Yeah.
have you noted that point about the duff points?
Uh, just a minute, sir.
Yeah, it's okay. Then I will explain the next point to you.
Yes, sir. I did it.
Now, the next point we have that is the main sequence. Main sequence. Have you seen that? Main sequence.
Yes, sir.
In some of the books, I have seen that the main sequence is given here. somewhere. I don't know why they have given there, but because this is your reference book, we will follow that. Okay. What do you mean by main sequence? Most of the star, most stars are found there, are found on the main sequence. Okay.
Yeah.
So the main sequence means there is most of the stars. It's fine. Yeah.
Yes, sir.
Okay. Let's discuss about the red giant also. Red giant. Okay. Let me write the about the red giant. So what is red giant? You have two types of the giants. You know that one is a red giant. Let me write with another pen. That giant means the medium star, as I told you, and one is a giant, super giant, which is the massive star. Okay, have the have low surface temperature. Oh, low surface temperature. Why the red color have the low surface temperature?
It has a longer wavelength.
Exactly, that's good. And high luminosity. Oh, again, luminosity is high, the temperature is low. That's another. And why the luminosity is high? Because now I am writing reason, okay? Because larger surface area. Because large surface area. Okay, that's fine.
Yes, sir.
Okay, now about this temperature, they have written that note that what we note that temperature axis is reverse. Oh, that's a very important point. Temperature axis is reverse. Do you think temperature axis is reverse?
Like, meaning that it goes to the negative side?
No, 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 no. It is from higher to lower. Higher
Oh, okay.
temperature is toward left. High temperature is towards left. Towards left. That's fine.
Yeah.
Yeah. Have you note all the points of the graph?
Yes, sir.
Note it, note it. Okay, note it. If any question you can ask now.
Wait, sir. So why is the temperature axis reversed?
Yeah, that's a very good question. What is the Wien diagram? Wien displacement law. Have you remember Wien displacement law?
Yes, sir.
Can you open the graph of Wien displacement law?
Yes, sir.
The Wien
Yes,
displacement law is telling us that when your temperature increases, the maximum wavelength going to decreases. Have you seen
yes.
that? So that's why they want to show there the temperature and the luminous relationship. So that's why they want to take the maximum wavelength at the end. So that's why they make the temperature in reverse form. Yeah.
Okay, sir.
Have you seen that? So basically, they want the luminous and the wavelength uh, on the x-axis, but they write it here temperature. So then they make the graph in the reverse form. Means at the end, when the temperature is low, your wavelength will be maximum. Your wavelength will be maximum. If your temperature is high, your wavelength will be minimum. Have you seen that? On
Yeah.
2500, there is a red wavelength, and the red wavelength is longer wavelength. And in 20,000 temperature, Kelvin temperature, you have the blue wavelength. And the blue wavelength is the basically shortest wavelength. Yeah.
Yes, sir.
Have you understand it? So
Yes, sir.
basically, they want to introduce or they want to explain the three concepts here. Okay. Okay. What is written on the y-axis? Can you see that?
Yes, sir.
What?
Luminosity.
No, not only luminosity. Be careful. What is written?
Luminosity compared to the sun.
Hmm. So that is the luminosity, relative luminosity. So if they says with the increasing temperature, with the decreasing temperature, high luminosity, so they are talking about with reference to the sun. Okay? Not
Yes.
independently, they are talking about with reference to the sun. Okay, it's fine.
Yeah.
Okay. So let me write the uh, have you noted that? So I can go to the whiteboard now.
Yes, sir.
Okay, have you noted that?
Yes.
Okay, let's go to the whiteboard. So now, what's a little bit I'm going to explain the words. Okay, so kindly write that when. Now I'm little bit going to explain the graph. When the luminosity, it's correct. I'm pronouncing correctly. What is that word? When the
Luminosity. Yes, sir. You're
okay,
doing it correct.
okay. I thought I'm pronouncing wrong. Luminosity of the stars is plotted against their, okay, remember what I am writing here, okay, against their surface temperature, okay. So it means the temperature which is related to surface area. Surface temperature, several classes of stars stars emerging, okay. So which we have seen in the graph, okay. This is the first point. The second point is that the temperature scale in HR diagram runs from high to low, because why we run from high to low? Because originally, yeah, Riem, are you there?
Yes, sir.
Okay, that's good. Originally, the graph was plotted using the peak emission of wavelength lambda maximum. Have you seen that? Which I have told you in verbally. I have written it now. Okay.
Yes,
This
sir.
this was later found was later found to be the property, sorry, to be the proportional to the 1 over T. is described by Wien's law. That's fine. So what
Yes,
is the
sir.
conclusion? Third point, the conclusion is important. The conclusion is that, so why I'm writing Riem, why I'm writing so much theory? Because this is important, okay? It's come into the paper. The
Okay.
conclusion about surface area is are based on the Stefan Boltzmann law. That is L is equal to sigma A T4. That's fine. Yeah. So it means in this law, they follow the both laws, the Wien displacement laws and the Boltzmann-Stefan laws. But the Wien displacement laws is lambda maximum inversely proportional to T, and the Boltzmann law is L is proportional to A. It's fine.
Yes, sir.
Okay, so this is the basically something about the graph. Now, let me write something about the. I know I'm writing too much theory, but
It's okay, sir.
okay, the main sequence stars. So let me write the main sequence stars. Okay, what are the main sequence stars? So stars in the main sequence. Let me take a sip of my tea. You can write it. Okay. Thank you.
Yes, sir. It's okay.
So I'm sorry for I cannot offer the tea for to you. So
No, sir.
so the star in the main sequence are fusing hydrogen nuclei into helium. Helium nuclei in their core. So it means the main sequence stars are the basically the stars which is have the starting age. Okay. Okay.
Yes, sir.
Now, so in this diagram, yani in the HR diagram, main sequence stars, main sequence stars messes. Sorry. Main sequence has stars stars masses masses increases increasing from bottom right to top left. Can you check from your graph? Is it this sentence is correct? The main
Yeah.
sequence star, which is the curve graph, okay?
Yeah. Yes, sir.
So it is correct. So this is the basically when the stars converting from when they are increasing their mass or decreasing their mass, that will take lot of time. Okay, that's fine now.
Yes, sir.
Okay, have you noted that?
Yes, sir.
Let me write a question, some example. Okay, let me write a sample question which is coming on this graph. The graph is that using the question which is coming in the paper. Okay, using the this is you write question working example. Okay, using the HR graph diagram above, the relative difference or in luminosity between a low mass and a high mass main sequence star. Fine. So how you going to do that question? You will do it that question like that. The low massive star luminosity is equal to 10 raised to power minus 4 of luminosity of sun. Okay. And the high massive star luminosity will be equal to, so this is low and this is high. Okay. It is
Okay.
10 raised to power 4 into luminosity of sun. So now you find the relative difference. No, how are you going to find the relative distance? 10 raised to power minus 4 luminosity of sun divided by 10 raised to power 4 luminosity of sun. So you will get 10 raised to power 8. It's fine.
Yes.
Okay, it is approximately 10 raised to power minus 8. Or you can write, okay, you can write it in word form. If it is, this is plus and this is minus, then you can find 8, okay, positive 8. That's fine.
Yes, sir.
So, so this type of questions can become into paper, okay? That's fine. So, but the diagram will be given to you. At the started, I have written using HR diagram, okay? The diagram will be given to you and then you will answer the question, okay?
Yes, sir.
Okay. Have you noted that?
Yes, sir.
Okay. Can I erase it?
Yeah.
Okay. Now, the next topic, we have the last topic of this chapter, that is the with you, okay? That is, I have left with the basic definition of gravity. Stellar life cycle means the life cycle of stars, okay?
Okay.
Cycle and the HR diagram and the HR diagram. Okay, so the what is my starting or opening statement? You can say the faith of the star depends on its mass. Remember that, okay? So the whole thing is basically moving around this thing, single thing, okay? That's fine. Yeah.
Yes, sir.
Okay, now let me write the stellar revolution. Now the stellar revolutions. Evolutions, not revolutions, evolutions. Evolutions. It's fine. So first write me the diagram and then I will explain you in the words, okay? First write me
Yes,
the
sir.
diagram, okay? So the diagram is like that, that you have the, okay, let me make the circles. Okay, just make me the circle. So for example, this is not a circular diagram. It is not exactly circular diagram, okay? It is roughly circular. It's fine. Yeah. It's like that diagram. Make it like that. So this is called basically stellar nebula. Have I made that diagram? I think I had made that diagram.
Yes, sir. We went through the life cycle of.
Yeah. So I have done it that.
Yeah.
Okay. So that's the diagram. So let me write their explanation with it. Okay. Now with respect to that, so stellar nebula. What is nebula? Nebula, or it is nebula. It's. Can you tell us what is this? Before this, we have the protostars. Protostars. Okay. This protostar is a basically combination of gas and dust. Gas and dusts. Okay. With high density, with high density and temperature. Okay. So remember that before this star nebula, we have the protostars, and the protostar is the gas with the high temperature and the density. Another thing which you remember, okay, I can write here, okay. So you can write it properly. Protostar, about the protostar, okay. So I'm writing these points now. The protostar is a basically gases and dust, okay, made from gases and dust. It's fine. First point.
Yes.
Second point, it has the high temperature, high density, and temperature. And it is continuously increasing, okay? It's not decreasing. It's continuously increasing. Okay. The third thing is that ProStar has its own gravity. Own gravity. Remember that. Okay. And this own gravity make it denser and hot. Okay. Make it denser and hot. And what is the gases there? The hydrogen gas. Hydrogen gas, hydrogen nuclei. Hydrogen nuclei will be there, okay? Or there, which is in together form due to high gravity, okay? Okay. And then this hydrogen, which is the basically isotope of the hydrogen, okay? Diffuse it and give you the helium, okay?
Yeah.
With lot of heat energy. Lot of heat energy. That's fine.
Yes, sir.
Okay. And there is another thing about that. that it emits then radiation. That energy, heat energy, is emitted in form of radiations. Okay, it's fine.
Yeah.
Okay, so this is the whole story about the, you can say, about that protostars, okay, which is before that stellar nebula, okay. Then the stellar nebula will form, okay, that's fine. Yeah, and I have made it the diagram. It's fine now.
Yes, sir.
Okay, let me now draw the that red giant, oh sorry, not red giant, the life of our sun on the HR diagram. Can you check it is the diagram it is made in your book? Let me check also. Yeah, that I found it. I'm sharing with you and then we will going to discuss. Okay. So that is the life of our planet with respect to, I think this is it. Yeah, I think this is it. Yeah. So I'm sharing with you. Have you write it from the board?
Just 1 minute, sir.
Okay, okay.
Yes, sir, I wrote.
Okay, now I'm sharing the graph with you. That is on the, I think, next two page, after two page. Have you seen that diagram in your book?
Yes, sir.
Okay, have you found it?
Yeah.
Okay, so basically in this diagram, this is the diagram about the life cycle of, you can say, have they written at the bottom? Have you seen that of this graph? They have written. It is the life cycle of the sun. Okay. Now, here, if you see that we have the red joint and we have the super joint. This is super joint. Okay. I don't know why they haven't write it, but it is a super joint here. Okay. Super joint. Basically, our sun is red giant, okay? Remember that, okay? The sun
Yeah.
is red giant, okay? Okay. So then we have the main sequence. Main sequence stars are protostars, and then they found the stellar nebula, okay? And after red giant, you find the white dwarf, okay? First, the sun is basically in main sequence star. Now the sun is red giant, okay? Now the sun will be convert after that white dove, okay? And then the sun will going to die. Okay. So
Yeah.
this is the life cycle of the sun. With this, the life cycle of the sun will be going to end. Fine.
Yes, sir.
And with this, our lecture, our basically